Okay, so your today's topic is history of space exploration. Okay, and some other things. It is not the only thing that we have. So along with there are some other things. Okay, people are actually waiting to do the drawing, but anyway, funny. It's okay. We delete all. They're all drawing. Just wait. Just give me some time to disable that annotation so that for drawing you cannot draw anymore. Okay. Okay. Now you can try drawing if you're interested, but okay, anyway, you cannot. Fine. So now let's continue with the topic. So it's about the history of space exploration. I will be giving some initial phase in well detail and the other things. I am actually trying to connect or touch the important things that happened in the history of space exploration, but not everything. So whatever I felt important, that will be added in this session, but it's not complete. Okay, so whenever you hear this topic, history of space exploration, as you know, it is actually a long journey. That is something happened from more than some 100 years of 125 years is already, if you exactly trace back to the beginning, it's almost some 120 years history. So 120 years of history we cannot anyway uh, cannot be included in a 1 hour session for sure, that so most important sessions are here, and I will whenever I am going through this topic, I will say you the important things, but the things will be in the slide that also you can read. Okay, so I am suggesting that don't stop there. You should read more about other missions that I have in discussed here. That is for your knowledge actually. And okay, so let's start. So this is a person called as Siolsky. So Siolsky is actually a Russian school teacher. Okay, he's not a we can call him a scientist now, but he began his life as a school teacher, and he is the first one, okay, to study in detail the use of rocket for space flight. Okay, and in 1903 or 3, his article exploration of cosmic space by means of reaction devices. Okay, so here you can see something called a reaction devices. Okay, I will explain that, laid out many of the principles of space flight, and up to his death in 1935, Siolsky continued to publish sophisticated studies on theoretical aspect of space flight. So he is considered to be the there are other historical evidences that people used some kind of rockets like the cannonballs or kind of thing. But anyway, a formal study of what is called the rockets actually came with Zyolsky, a Russian school teacher and a mathematician. Okay, so anyway, reaction device means that is where the rocket comes. So here, this meaning, okay, the word meaning is actually, we can simply translate into rocket actually. So because rocket is a reaction device. So what do you mean by reaction device? So in the speciality or the problem in space is already we said yesterday, that is it is empty, it is a vacuum, so you cannot actually fly anything there. Okay, I'm not talking about the Mars is actually has some atmosphere, so Ingenuity can fly there, no problem. But anyway, for the case of rockets, actually the rocket can actually it's not flying, it's actually working by a principle called Newton's third law, where every action has some kind of a reaction is there. So here what is happening, this entire body of the rocket is filled with the fuel, and when this fuel is burned, okay, there is no wheel or anything to, or any no flying things, something like the flap or wings are not there, but only thing it has is actually this nozzle through which the exhaust is going. So when the exhaust is going in this direction, the reaction of that will actually happen on the, or that reaction is actually on the rocket body. Okay, it is something like, imagine that you are standing in space, and if you throw something, when you throw something, you will also go back actually. So another better example is actually an example of action reaction. It's actually, suppose you have a gun, imagine a long gun, and if you try to shoot, started to fire from that. Okay, so if you are firing from that gun, actually when the bullet goes in this direction, entire gun will actually go in this opposite direction. That is called the recoil of gun. So the recoil of gun is also there. So that is also another reaction. Similarly, when in the case of rocket, when the fuel burns and that exhaust is going in this direction, rocket get a push in the opposite direction, and that push is the reaction. And here this is the action, which is the flow of the exhaust gas, and opposite there will be an action, reaction, the opposite of that, and that reaction. So that is why he said his paper or his article says that exploration of cosmic space by means of reaction devices. So rocket is an example for reaction devices. So another second person who is important in the history of space exploration is actually Robert Hutching Goddard. So you might know that the Goddard Space Flight Center and all. So that is in his name. Okay. Even as a young man, he dedicated himself to working on space flight. And very interesting thing that even you might be dreaming some days. That is, especially since you are a school student, it is just imagine how he imagined or what was his vision even at that time. Or maybe it is, we cannot call it as a vision, or maybe it is a dream actually. So the dream that is happening at the age of school time can sometimes fulfill when they become an adult, maybe at his young age. Okay, so here you can see it is difficult to say what is impossible, for the dream of yesterday is the hope of today and the reality of tomorrow. So this is from the words that he said during his high school graduation. An interesting thing is that when he claimed initially that the rocket could be used to send object as far as moon, was widely ridiculed in public press actually. So see here, the people ridiculed him that it is not even possible, because saying this in the initial ages of 1900s or something in the 1900s, people may actually ridicule him, like even the press, especially the New York Times actually ridiculed him when he said this. And later, after the moon landing, they actually retracted and said sorry that something that is a wrong statement they had actually. So this shouldn't have been happened. So like that even has been. That is something called, see how the history changes. Okay, then he was a professor and his rocket launched in, and later he designed a rocket and his first rocket launched in Auburn, Massachusetts on March 16, 1926. It was 12.5-meter high. It's actually not that high anyway, but you see even that beginning is actually using a rocket. The technology is there. Okay, so an interesting thing, the noisy character of his experiment made difficult for Goddard to continue work in Massachusetts. He moved to Roswell, New Mexico, where 1930 to 1941 he built engines and launched rockets of increasing complexity. Now, another second person who is important in the history of these, or the third important person, is Oberth. Okay, widely recognized pioneer of rocketry. Hermann Oberth was birthed by Romanian, by nationality he's a German, and so Oberth 1922 doctoral dissertation was on rocket powered flight, was rejected by the University of Edinburgh. See here also in 1922 his thesis got rejected. So, and here in the case of Goddard, actually you can see the press actually ridiculed him, and see what happened later. Okay. So and he worked in a group actually, and that, just a second. Sorry for the gap post. Okay, so anyway, and again, his doctor dissertation even rejected, and they formed a rocket, that a team actually. The most important of this group historically was this one. I don't know how to. The translation is Society of Spaceship Travel, which had as a member of the young Warner Braun. Okay, so it is they had a group of rocket club. So there were a number of rocket club actually came in Germany, and one of them is this one, Society of Spaceship Travel. And Oberth's work was crucial in simulating the development of rocketry in Germany. He himself had only a limited role in that development. Okay. So he was not an engineer to develop it, but in simulation part actually his role was crucial. So alone among the rocket pioneers, Oberth lived to see his ideas become reality. He was Braun guest on the, July 16, 1969 at the launch of Apollo. So this is the launch of Apollo. Okay, launch date is July 16, not the landing date there. Okay. Now, other space pioneers are also there, like Tsiolsky, Goddard, and Oberth. There are many people are there, and two of the examples are a French man called Robert Esnault, and began his work on theoretical aspect of spaceflight as early as 1907 itself. And another in Austria, there is Eugene Sanger, worked on rocket engines, and in the late 1920s proposed developing a rocket plane that could reach a speed exceeding 10,000 km per hour and an altitude of 65 km. So, interested in Sanger's work, Nazi Germany in 1936 invited him to continue his investigation in that country. So, why Nazi Germany should have called him? The issue with or the speciality with the rocket is actually, so you will see in the next slide that the issue of rocketry or the issue with rocket is a problem with rocket is maybe rocket can be used for two purposes, something like either you can use it for to explore space, or at the same time it is useful for war as well. So that is why it is that is how it is developed actually. The if you take the history of Germany, actually the German V2 rockets, okay, they are actually missiles. So those missiles are actually, then they studied the working of those German missiles, and that is how America and Germany, America and Russia actually got that technology. And they, after the World War II, they even took the scientists to USSR and USA, and with the help of them, they actually developed. So the Germany, that is, it was a space exploration that motivated the members of that German VFR team, that the space club, to build their rockets. But in the early 1930s, their work came to the attention of German military. Okay, because for military, the rockets are needed not for a constructive purpose or a positive purpose, but for war actually. So in 1932, Werner von Braun, at the age 20, became the chief engineer of rocket development team in German army, and Adolf Hitler came to power in 1933. Braun was named the civilian head of the team. To give Braun's engineer the need to space and secrecy for their work, German government erected development and test center at the coast of Baltic Sea. Okay, there they developed, among the other vehicle, the V2 ballistic missile. So this is the German V2 rocket. Okay, and it launched successfully in 1942, and V2 was used on target in Europe beginning in September. So it is actually used there for war purposes. Then, although built as a weapon for war, the V2 later served as the predecessor of many of the rockets used in the early space program in United States and Soviet Union. See, so it is actually the predecessor. Okay, so this is why actually the countries, even now, the countries won't share their rocket technology, because this rocket technology is closely associated, or it is mostly associated with the defense as well. So that is why they won't share their technology. Okay, so that is why maybe India, or sometimes actually they have to develop their own technology, or every country try to generate their or create their own technology for them, indigenously try to develop. So as World War II neared its end in 1945, Braun and many of his associates chose to surrender to United States, where they believed they would like to receive support for their rocket research, okay, and space exploration. Later in that year, they were taken to United States as where their engineering plans and the parts needed to construct the number of V2s. The German rocket team played a central role in the early development of space launchers for the United States. Okay, so, and this history actually doesn't only happen to what is called the Germany only, or in not just in the rocket science. Every science field actually, just after the war, there were actually scientists either choose to go, or they surrender to USSR or to USA, so that either of those countries will be chosen by them, and they will go there. Especially they wanted scientists. Okay, so that is how important the scientists are, or the scientific community is wherever it is. Okay, so even when there is a war in a country or something, so their scientists will be protected the most. One of the most protected people will be the scientist, because that is who they are actually gonna build the upcoming advancement for that country. So that is why we have to that is why we learn science, as well as also we have to invest more in science. Okay, invest in the sense the budget should be more allocated on science. That is why we are saying. Now, in the case of United States, the same, the 1936, that is, this team actually came, and the German military served several young American engineers led by graduates. Student Frank Malina began working on rocketry at the, this is a facility, that is the Guggenheim Aeronautical Laboratory in Caltech, that is the California Institute of Technology, and their group, Malina's group. So that group is actually called the Suicide Squad. You can see that team actually, because all the experiments were something, you know, that it's, since it is rocket, it is dealing with explosive. Okay, then Malina and his associate began calling their group the Jet Propulsion Laboratory, that you know. Okay, so this Suicide Squad is kind of a nickname, and this is the proper name they had chosen, the Jet Propulsion Laboratory. It still exists, you know, that JPL, NASA. Okay, and that was formally adopted in the following year. Yeah, JPL soon became the Center for Missile Research and Development for the US Army. Following the World War II, those weapons were adopted for use in early space experiments. Okay, so initially it was for war, then later it is being used for US space experiment. After 1958, when they become the party of the newly established national era, that is NASA, JPL adapted itself to be, being the leading US center for solar system exploration. Okay. Now, the Soviet Union, this is happened in USSR. The government took an interest in rockets as early as 1921 with the founding of a military facility devoted to rocket research. Again, this is happening for the military facility. Over the next decade, the center was expanded and renamed as Gas Dynamics Laboratory, or GDL. There in early 1930s, Valentin Glasgow, carried out pioneering work on rocket engines. Meanwhile, other rocket enthusiasts in Soviet Union organized into societies, that is, that by 1931 had consolidated into organization known as GERD. Okay, that is Group for Study of Reactive Motion. Okay, with the branches in Moscow and okay. So then, actually, by the end of that, maybe at the time of Stalin, by the end of the war, Stalin had become interested in ballistic missile and sent a team which included the Sergei Korolev. So he's an important engineer in the Soviet Union, and included Korolev. Korolev and team actually sent to Germany to investigate the V2 program. Anyway, a number of German engineers were located to Soviet Union, like that of the US, and aftermath of the World War, but they did not play a central role in the post-war Soviet rocket development. Actually, in the case of US, actually this migrated relocated people, actually scientists and engineers actually played a crucial role in the history of US. But in the case of USSR, actually they haven't contributed much. Okay, but anyway, they developed their own rockets. Okay, now begins just after this Cold War. After especially at the ending time of the during the war itself, during the Second World War, and at the end. Okay, so there is something called a space race has started. It started with something called a Cold War, that is a rivalry between United States and the Soviet Union, or USA and USSR. It began in the late 1940s and early 1950s. Okay, late 1940s and early 1950s. That is actually after the war. Okay, after the World War II. Okay, during the early stages of Cold War, both superpowers aimed to showcase the superiority of their political ideology, that is capitalism. One is a capitalist country, another a communist country, or a socialist country, and so they were trying to showcase their superiority in any field, not just the field of space, but anyway, here in the space as well, they actually try to showcase their superpower. And the competition was largely fueled by military interest, and space technology was closely tied to missile technology. So both nations used space exploration as a way to gain international prestige and demonstrate their technological dominance. And this is the Sputnik 1. So it actually officially, when the space race started, that we see as by the launch of Sputnik 1 by the Soviet Union on October 4, 19 57. So October 4 to 1 week is actually celebrated as the Space Week as well. So if you remember, that is in that happened. Okay, is widely considered the official start of the space race. Okay, Sputnik 1 was the first artificial satellite to orbit the Earth, and its success shocked the United States and led to uh, fears of Soviet superiority in ballistic missile technology. In response, the US accelerated its space program, leading to the creation of NASA. And in response to that, actually, they launched their first satellite, that is Explorer 1, that is here in this picture. The first successful US satellite launched on January 31, 1958. Okay, so that is how the space race began. Then you can see, so this is the in short of the space race is. So here you can see the first, it started with the launch of Sputnik 1. Okay, so the first satellite. Okay, so yeah, okay, that is Soviet Union. Then launch of Sputnik 2 with Leica, launch of Explorer. So you see this is happening in a series. It is almost continued. 1957, 57, 58, 58, formation of NASA, then 1959 launch of Luna 2, then Yuri Gagarin in Vostok 1, Alan Shepard in Freedom 7. So see, Yuri Gagarin went first in 61. So in that May itself, then Alan Shepard went to space. First American in suborbital flight. Okay, so this is suborbital, this is orbital, means actually Yuri Gagarin went on a complete orbit, but first American, Alan Shepard, is not completed a complete orbit. It is something like a partial orbit and came back. Okay, anyway, he was the first one to reach the space for US actually. Then moon landing. This is happened in 1961. John F. Kennedy's speech on moon landing space. That is, he said that by the end of 1960s, that means at the just before the 1970s itself, the Americans will land men on moon. So that is the famous speech by John F. Kennedy. And okay, they accelerated their research and all. In 1962, John Glenn in Friendship 7, that is first American to orbit the Earth. Okay, then Alex Leonov spacewalk, Soviet Union, Luna 9, that is Soviet Union. Then Surveyor 1 moon landing, Apollo 1, that is a tragic accident actually. That is part of the. And after the Apollo 1, they actually developed some fire resistant and heat resistant material for Apollo. So that later used as the by firefighters and civilian purposes. Okay. Then Gemini missions by US, then Apollo 8, first human to orbit the moon and return safely. Apollo 11 moon landing, that is Neil Armstrong, Buzz Aldrin. And Edwin Aldrin and Buzz Aldrin are the same person. Okay, the name is something like Edwin Buzz Aldrin. So become the first human on the. So sometimes it is used as Edwin Aldrin, sometimes it is used as the Buzz Aldrin. Okay. Then Apollo 12 to 17 mission. Okay, 17 was the last mission. So here for landing, actually they won. Then launch of Salyut 1 space station. So then they started the era of space stations, something like the International Space Station. So Salyut 1 was by Soviet Union world's first space station. Then the launch of Skylab, which is another space station, that is by United States. Then actually a former end of this rivalry, a friend, what to say, a productive rivalry, actually ended by 1975. That is by a test project, that is actually a collaboration between. So here up to here you can see okay, now you can see this is USA and USSR together. Apollo Soyuz test project, first international space dockings. So they are actually docked to a spacecraft together, that is one by USA and one by USSR. So first international space docking symbolized the end of the space race. Okay, so that is how it gone. Okay, so even this is not just a development that is only happened in the space in the ways that when developing all these rockets and other technology that needed for that, actually they were creating more material, maybe many other good things that is later come to be used for other purposes. They are called as spin-offs. So we will discuss about spin-off at the end. So anyway, that is it. So if there is a war, that should be like this. Okay, anyway. other than using some weapon directly, it is better actually. So in the sense that who is better. So anyway, that will progress overall science. Then collaboration and end of the space. Apollo Soyuz test project in 1975 marked the first joint US-Soviet space mission and symbolic end to the space race. It involved docking US Apollo spacecraft with a Soviet Soyuz, signaling the beginning of space cooperation. Then the event showed a shift from rivalry to the easing of Cold War tension. Okay, so the space race accelerated the development of rocket and satellite technology, and these are all the advantages that is actually happen. Then the legacy of the space race continues today in the form of international space cooperation, like the International Space Station. Even in International Space Station, actually many countries are together. Even USSR is also, they have their place there, and it's a collaboration between all these many space agencies, JAXA, USSR, and USA, etc. So that is where it is going, or it is right now. Now then comes an important type of space vehicle which is not currently being in use, but it served as a very important thing, especially in the development of what is called the building of that International Space Station. It actually had a major part, or it spent a major role in that. That is the space shuttle. So space shuttle is actually designed to one concept is actually develop a reusable transport vehicle. That is important. So in the case of usual rockets, you know that nothing is reused. Okay, so people will go there and come back. Maybe that space capsule, that is one thing that returns if it is a manned mission. And anyway, space shuttles are for manned missions or crewed missions. So when this crewed missions goes, the problem is that if it is a normal rocket, only the space capsule remains. Other part is actually getting useless. So that is why NASA received an approval for developing a reusable transport vehicle. Okay, that is called the space shuttle. Okay, so it was expected to operate at a low cost and replace all other US vehicles. The shuttle should also serve as a space platform for research. Okay, so this is something like, it's actually a flight in an orbit. Okay, so if you look at here, other than this 1, 2, 3, so this is a fuel tank, and these two side ones are called boosters. Okay, and this main one is that flight. Okay, so it is actually something looks like a flight that is kept on a rocket. It's exactly the design is like that. Okay, so the one that to go, it rises together, and when this fuel is burned completely, they will actually go to the sea, and this actually the boosters will be reused. Okay, solid rocket boosters were recovered and reused, but this center part is a liquid fuel that won't be reused. Okay, but that becomes useless. But anyway, this entire flight is being used later. Okay, and it is actually going to fly. Then when it comes back, okay, comes back to Earth, it will finally land like an aeroplane to a to a station. Okay, to an airport. Okay, a kind of an separate airport will be there, and in that separate airport, that can actually land like, it is not like a splashdown that we usually see that they are landing to the sea or something. It is actually something like it will come and land like an aeroplane on the port actually. So that is how it was working. And the names of there were actually 4 of them. That is, one is called the Columbia, Challenger, Atlantis, and Discovery. Okay, so these were the names of the 4 orbiters or 4 space shuttles they built. Okay. Okay. Then space shuttle mission, I'm not going to explain it completely. And actually, two major disaster happens. One is the Challenger disaster and the Columbia disaster. So in Challenger disaster that happened in 1986, it actually exploded just 73 seconds after the launch. So this is the photo of that is actually getting what is called that explosion that happened just after 73 seconds after the launch. Actually, now there is a Netflix documentary there on this space disasters. Actually, I think Challenger is also there in that documentary series. It's there in Netflix now. Okay, all 7 crew members died, and including a teacher. So a teacher was also taken for this mission. So the fail was there is an O-ring seal in the solid rocket booster. Okay, So actually O-ring means it is something like a rubber washer, okay, something like a ring, okay, which is actually sealing the solid rocket booster. But you know that since the temperature, it was a so you can see it is in January, that means it's a winter. So in that cold weather, that so when you use something like a rubber material, like a O-ring or a washer or something like to a contact in between, it has to be something, it should have an elastic nature like a rubber actually. But due to the cold weather, it become brittle, and because of that, the booster struck the external tank and igniting the fuel and causing the explosion. So some leakage happened because of the brittleness of that O-ring. So that is happened. And for the replacement, they actually built the Endeavour one. Anyway, then again also, even though it is this disaster happened, post Challenger safety protocols were strengthened, reducing flight frequency. Then the shuttle demonstrated capabilities like satellite repair, and if you remember, the satellite repair is actually about the Hubble, okay, in orbit science. Okay, from 1998 onwards, shuttle helped in assembling the International Space Station. Shuttle conducted 37 missions related to the International Space Station. Then comes in 2003. This I remember when I was in school class. Uh, I was in 7th standard, if I remember. Yeah, on February 1, 2003, Columbia disintegrated during its re-entry. It happened actually during the re-entry, and all 7 crew members died, and the shuttle fleet was grounded again during the investigation. And it had the issue was with the heat tiles. So it has some, when it is coming back to the atmosphere, it will generate a lot of heat due to the friction between air and the flight. So there is something to avoid that. There were some heat tiles. So even at the time of launch itself, when they reached there, already something happened for that heat tiles, and later that is the cause of that disaster with the heat tiles. Okay. Then in 2004, George W. Bush officially announced that the shuttle would retire after ISS assembly. Okay, and final shuttle flight occurred in 2011, okay, July. Over its lifetime, shuttle flew 135 missions, launched 355 different people into orbit. So even though it is kind of a disastrous things happen, but it is actually uh, did a great thing, especially in assembling the International Space Station, and also this crewed missions and repairing Hubble, etc. Okay. Now this is another. This is I included specifically because this shows how people collaborate in space, even though there might be some issue between the countries and all. Okay, but anyway, here you can see the people are actually, or the different countries like the USSR or USA, and even maybe in ground there might be tension, but they are actually collaborating in space. So that is a perfect example. That is why the name International. It is not an American space station or anything. It is actually International Space Station. And initially, it actually NASA thought of making their own space station, but then the budget actually it's not affordable for them. Not in the sense affordable in the sense it's affordable for US, but the government is not willing to uh, give that much amount. Then what they did, they redesigned an international collaboration. So in 1993, US and Russia merged their separate plans, and ESA and Japan jointly as the key partners. Okay, so then the project included contribution from Canada and 11 ESA member nations. So European Space Agency is actually not just, as you know, the Europe is not just a it is actually European Union consists of many member nations, so they are also contribute. Okay, so in 1998, the first module launched. So the first module was Russia's Saria, okay, followed by US modules, US module, that is Unity. So it is actually different parts. I will show you a time lapse video of how they actually arranged all this thing. Then Sveda module added in 2000. First crew, 2 Russian plus 1 American arrived on 2000 November 2. Okay, construction continued with the addition of Destiny Lab, Columbus Lab. So these are all different labs actually, or something like different rooms we are adding. Okay, or different capsules we are actually connecting together so that it will completely work as a single one. Okay, so it is something like a Lego toy, something, a building block actually. We are taking one piece and attaching to the remaining like that. Okay, so now, okay, here you can see this is the each part. It's a fast time-lapse video, a GIF basically. See, this is how they connected. You can actually see here every name is actually there, but it is so fast forward one 2011. Yeah, this is how they. So actually, you can see that the solar panels are actually rearranged later. Something like, yeah, it comes or is in this direction. Yeah. So this is the International Space Station. So then ISS, the key challenges: 2003 Columbia disaster, post the station expansion, crew reduced from 3 to 2, science operations limited, because we need a proper vehicle to go there. But anyway, the even before that last SpaceX and all, actually, the Russia's rocket is the one actually used for almost all the International Space Station missions. And but sometimes it is SpaceX also used, especially for cargo. And last, you know, that in this year in February, March, maybe 1 month before, actually they use SpaceX to return this Sunita Williams from there, that and his friend from there. Okay, okay. Then ISS has been continuously inhabited since November 2000. More than 200 astronauts from 20 plus countries. So that is so important. Okay. And US, ESA, Japan, and Canada plan to support ISS through 2030. And Russia actually going to plan to exit from this cooperation, and they are actually planning to develop their own space station. Okay, and this is a website, web address. You can actually see where exactly this space station is right now. Okay, where it is actually. So something like, show you that. See, this will show you that where it is. Just wait for a while. Yeah, see, now it is here. It is in the night side, and it is crossed here. Okay. So you can see it is at a height of 437 kilometer, and where it is located, what is the latitude, longitude, and what is the speed with which, see, 27,531 kilometer per hour, and the date is like this. So that's it. Okay, anyway, let's go back. Now, I'm not going for a detailed talk about any of this topic. We are running up to time. That is one issue, and this is history. So anyway, I will describe some of the major events that happened from 1990 to 2023 or 24 in space missions. Okay, so the 1990, the Hubble Space Telescope launch, that we already discussed in detail about that. Then the Galileo arrives at Jupiter. That means it is not the Galileo Galilei. That is the first orbiter at Jupiter, studied its moons and atmosphere. Then Mars Pathfinder plus Sojourner rover that we discussed last time. That is the first successful rover on Mars, tested new technology for space exploration. Then International Space Station assembly begins. Then that is NASA and Roscosmos. Roscosmos is the Russian space agency, and plus other partners like ESA and JAXA, etc. Multinational collaboration in building an orbital lab. Okay. Then permanent crew begins on ISS in 2000. Then Mars Odyssey orbiter launched. Then Spirit and Opportunity rover launched. Then Shenhao, first Chinese human space flight in 2003. Cassini-Huygens reached the Saturn, that we discussed yesterday. If you remember, that Huygens was something, a probe used to study the Titan and all. Then this is Spaceship One, that is another important thing in 2004. That is the first private manned suborbital flight. So this Spaceship One is the private one. Okay. Then New Horizons launched to Pluto. Then Chang'e 1 lunar orbiter by CNSA. That is the first Chinese lunar mission, marked the start of moon program. Then Chandrayaan 1 by Indian Space Research Organization, first Indian lunar probe. And an important discovery was actually the confirmed the presence of water on moon. Okay. Then Jules Verne ATV launched by ESA, that is Europe's first automated cargo spacecraft to International Space Station. Then final space shuttle flight in 2011 that we discussed. SpaceX Dragon docks with ISS, that is first a commercial spacecraft to deliver cargo to ISS. Then Curiosity rover lands on Mars. Okay, then Chang'e 3 soft land on Moon. Okay, that's the China's soft landing. Now, again in 2014, Rosette Philo lands on Comet 67P, and New Horizon flies by Pluto. If you remember, I don't know whether you remember 2015. Probably not anyway. So there were a picture of Pluto with a heart shape. There was some land features where there it looks like a heart actually. That picture was famous at that time. Now ExoMars trace gas orbiter, then Parker Solar Probe, that is the closest ever approach to Sun, studies the solar wind. Okay, then Bepi Colombo launched to Mercury, then Chang'e 4 land on Moon's far side. First all female spacewalk that is happened in by Christina Koch and Jessica Meir make history in October, that is in 2019. Then 2020 Crew Dragon Demo 2, first crewed launch, SpaceX and NASA. Then Hope Mars mission, that is by UAE, first international mission from an Arab world. Okay, then Tianwen 1 Mars mission launched by CNSA. Then JWST in 2021. Then Inspiration 4 mission in 2021, that is actually by again SpaceX. Then you can see that after that time, SpaceX is also coming into the play. That is a private party that is coming into the space industry. And most of now, as you know, NASA and ESA, NASA is actually using many of the Falcon 9 and those vehicles actually. Then Chandrayaan 3 lands near the Moon's south pole in 2023. So India became the first country to land near the lunar south pole. So that is a brief important things. Surely there are missed things there because we cannot give all of them together in this timeline. But if you go to Wikipedia, there is a specific page there that is about the timeline of space exploration. Okay, so where you can get the entire history. That it's pages long, but you can actually read or when you want to refer. But Wikipedia, as you know, it is not an official reference because Wikipedia is editable. Even I can go and edit my name. Okay, I can put my name as Indian president, maybe, no problem, or US president, I can edit. But you know that within seconds it will be changed. The people are actually correcting it as well. But anyway, whenever you are taking data from Wikipedia, you check with the reference. There will be a number in the bracket. That number is actually giving a reference. Go to that reference and verify. Okay, so that is important because a lot of fake news can happen anytime. So now this is a comparison between the space agencies, okay, or not a comparison basically, it is a brief about different space agencies, different important space agencies. So the space agencies given: NASA, ESA, JAXA, CNSA, Roscosmos, and ISRO. And I'm giving SpaceX for an example of a private one, okay. And the head, you can see Janet Petro. Then here the director general is some Joseph Ashbacher. Okay, I don't know how to pronounce. Then Hiroshi Yamakawa was the president of JAXA. So I'm not reading all this. You can actually read, actually, it's better. And the headquarters are there. Then motto, each of them. And you can see, for the benefit of all, United Space in Europe, then explore to realize space dream, then making life multiplanetary. So you can see making life multiplanetary. That is why they are actually always wanted to go to Mars and all. Okay. Then India, you can see space technology for national development. That is the basic motto. Then you can see the annual budget spent by each country. Okay, so it is 25 billion is by NASA, and all other is not that much. Okay, NASA is spending the most, and that is why whenever you hear news about NASA or space, you will hear mostly that's NASA again. Okay, because their annual budget is that much when compared with other. Okay, so it is just, you see, when compared with the major other, it is, even in the case of, if you could compare it with India, it is 2.1 billion. It is more than 10 times. Roscosmos also, if you consider, it is almost 10 times. Okay, and major launch vehicle Falcon 9. Falcon 9, again, I said that it's actually via SpaceX. So there is collaboration between NASA and SpaceX. Then Ariane 5, 6, that is from ESA. Then H2, AH3. that are from JAXA, Long March series from CNSA, Soyuz, Proton, etc. from here, PSLV, GSLV, SSLV. SSLV is a small satellite launch vehicle, and LV-M3 from ISRO, then Falcon 9, Falcon Heavy, Starship in development. Major human missions, as you know, Apollo shuttle, then ISS, then Artemis, the major human missions, okay. Then ISS astronaut via NASA or SpaceX, then ISS crew, Kibo Lab for JAXA, then these are all mission for CNSS mission. And I think, yeah, almost all the space agency, except ISRO, has actually a human mission, but for ISRO, it is under development of the Gaganyaan mission. Actually, it's planned. Okay, already they chosen the astronauts itself. Or okay, now whether they own a space station for NASA, actually they have not their own anyway. They are ISS partner, but China has one, that is the Tiangong, their own ISS partner. Also, India, even though it is not a part of any space station, but India is actually planning for a space station called the Bharatiya Antariksha Station, and SpaceX also doesn't have one, but it supports ISS. Then planetary missions, you can see these are all the major planetary missions. I'm not saying that if you take the case of this NASA and all, you have to, NASA, ESA and all, you have to fill it with many, and also with Russia. The major things are actually written, and here when you read this thing, you don't think that this is the only thing they have. Okay, major things are. Now satellite programs, Earth observation satellites are there, astronomy satellites are there, then GPS is there. Then for ESA, Copernicus satellite system, Galileo, that is their navigation satellite system. Here also JAXA also has, yeah, Earth observation, astronomy. Then GLONASS is actually the navigation system by Russia, and Earth observation. NAVIC, if you know, that is actually the regional navigation system by India. Okay, then Starlink, as you know, that is the satellite largest satellite constellation. Then notable first moon landing, first comet landing by ESA, that is the Rosetta mission, first comet landing. Then first asteroid, okay, so this is an important mission, okay. First asteroid sample return, that is actually Hayabusa. Then first Mars orbit and rover in first mission, CNSA. So this is actually first Mars orbit and rover in their first attempt. That is the meaning. It doesn't mean that CNSA or the China did the first Mars orbiter. Okay, they attempted it. They succeeded in the first itself. Okay, so that is here. Then first satellite in space. Then first to land near the moon's south pole. Then first private crewed orbital flight. Reusability focus, so space shuttle they had. Now the Artemis also actually a reusable, and also in partner with the SpaceX is actually Falcon 9 and Starship is actually planning for a it's actually a reusable vehicle. Then India is actually in development of a reusable vehicle called RLV, reusable launch vehicle. Okay, now this is intergovernment, means 22 European Union nations are there in ESA. This is NASA purely government, then JAXA, CNSA, Roscosmos, and ISRO. Okay. Then future missions are this: Moon, Artemis, Mars Gateway. Then here also you can see crewed moon landing. The China is planning, that is CNSA. And for India, Gaganyaan, Venus, and human space. Human space flight is the Gaganyaan and Venus mission, and Bharatiya Antariksha Station. These are all the future. And an interesting one from SpaceX is, as you know, the Mars colonization. Okay, and also the global internet by Starlink. So these are all the future goals by all these countries. Okay, so I have put this in a table so that we can actually cover this more topic in a short time. Okay, now let's go ahead with the space spin-offs. Okay, so spin-off means, as you know, it is actually there are technology which develops for some other purpose. Okay, and but it widely used in other than that. Okay, so that idea is actually, or that kind of things are sometimes called as space, basically spin-offs. Okay, so concept is we develop something. Okay, we develop something Maybe here space spin-off means we develop those things for space, but it is later used for other purpose. Other means especially for civilian purpose. The common people actually become beneficial of that space or maybe any other. So it is also known as, sometimes when you search for space spin-off, also you can search for technologies transfer. Okay, space technologies transfer. This is also another word that is used for spin-offs or instead of spin-offs. Okay, so that is space spin-offs. And some of the examples, only few of them, there are plenty actually. I will go through this and I will show you an interesting site regarding that after this. Then one is cordless tools. Okay, so you know that cordless vacuum cleaner, cordless drill. Okay, some kind of drill bits are there. So actually NASA, when they went for the Apollo mission, when people went there, they actually wanted to drill the surface of moon. Okay, so but the problem is that actually they cannot carry a wire from the, they can actually do from an additional wire from the lander and then connect it with to get the power. So instead of that, actually they developed a battery pack, a drill bit with the battery pack, and that is nowadays actually we use that cordless thing. And cordless vacuum cleaners are there. The concept is actually came from the same. So from the cordless tools, the concept of cordless tools actually came for the development or to be applied in Apollo mission. And another one is actually scratch resistant lenses. Okay, so if you use pure glass even got scratch anyway, it's less than that, but some of you may actually have something called a specs actually. So in the case of specs, it is actually made with a kind of a plastic. Actually, it is not actually made with the proper glass actually. So it is actually good in the sense that it can actually absorb a kind of ultraviolet and all, it can actually absorb, but at the same time it will be lightweight as well if you use instead of glass, if you use this polycarbonate material. Okay, that is why the glass nowadays our specs glass won't break actually. That is because it's a plastic kind of material, but it can get scratch easily since it is a plastic. But there are scratch resistant coating that is available for all these glasses, that is actually used not for our specs or anything. It's actually found for the glasses that they use in that helmet. That space helmet has a glass, that visor, that glass has actually a scratch resistant coating which is developed for space. Again, it is actually in the space suit and that space helmet. Now it is used in widely, or in every glass it's actually used. Okay, so that is the scratch resistant lenses. Next, another most important thing, that is digital camera sensor, or basically we can say that you all have a camera in your laptop or maybe in your mobile phone. So it's that accessible a camera is, and camera becomes digital and it becomes cheap. Okay, so we had two type of sensors. One is called a CCD sensors. That is the one thing that they had initially, but the problem is the CCD kind of is, it's very slow actually, but it is still used in telescopes in the sense that it is so very good accuracy is there. But in the case of CMOS sensors, that kind of a sensor, the sensor name is what is I said, that there are two type of sensors, CCD and CMOS. Okay, so CCD is an old technology, but it's still used because of its accuracy and all, even though it is slow. But CMOS is so fast and it is actually used even now. Every mobile camera and every camera nowadays doesn't use any films at all. You don't even remember the what is called the film, what a film is, but there were some chemical thing was there. Maybe when I was a child, the cameras were like that. Okay, but now we have digital camera because of space. So the CMOS sensor technology is actually developed for space missions and by NASA again. Now, enriched baby food and many types of baby food formulas, especially enriched food means, you know that when we go to space and stay in space, we need food. Okay, but we know that if you take the food, the normal food, the problem is that it doesn't normally it doesn't have enough macronutrients and all, so they have to be enriched. Otherwise, if you want all the kind of macronutrients like zinc, potassium, or all these things, then they have to take more food, okay, which contains this. So the problem is that then the load, the weight will increase, so that then the rocket has to carry all this weight. So it is better to enrich the existing food with the other macro and micronutrients so that it will be more healthy. So that is the same thing actually used for baby food technology. There is one more food technology is there. If you go and watch the videos of ISS, so ISS food is actually kind of, most of the foods are actually kind of a dried food actually. So it is something like, it looks like dried. When you pour hot water inside that, it becomes a normal curry like. Okay, you can actually get that kind of food even in market right now. So when I was in some working in that observatory, actually I cannot taste my homely food there. Okay, which is actually in uh, a farther away village, and it's far away from my home actually in North India. So when I was there, I cannot actually get my normal food, but there are packaged food which is actually uses the same rocket technology and or space technology, so that it, there will be any type of curry will be there, whatever I like. Okay, so those curries actually available in my market, so that it will be dried using special technology. All the bacteria will be removed from that using some UV and all, then safely packed, so that just heat it in a microwave or maybe pour some hot water, I can have it. So that kind of thing. Then another thing, memory foams. So some, you know, that very comfortable bed or cushion like of thing, that is actually also designed for uh, in the case of it's actually designed for space. That is also another example. Then there are many, I'm not going to describe all of them. Something like the water purification system actually developed for NASA. Then firefighting equipments, then insulation and thermal protection, structural monitoring system. That means to so if you structural monitoring system means when you build something, how stable it is or how strong it is has to be checked. Okay, so that checking is always needed for what is called the space technology, whether a rocket could withstand this pressure or something like that. Okay, so for that there are many monitoring systems that is actually developed for space, but it is still being used in other industries as well. Then this is especially by actually there are spin-offs from ISRO. That is one of them I have included, that is left ventricular assist device. You can see that this is a assist for the ventricular valve or something. I don't know exactly the biology behind that, but that material that is used to make that assist thing, because it couldn't be heavy, you can see that it is actually kind of a sagging from that heart, and also they used a lightweight rocket material. ISRO had developed low-cost heart pumps that assist the human heart, notably in case of left ventricular failure, ventricle failure. Okay, so that is about it. Okay, it's a kind of a pump, I think, instead of the ventricle. Ventricle is one of the that chamber. Okay, if I remember correctly, the biology class. Okay, now that's about the syllabus. The syllabus almost covered. Okay, so anyway, you can read the details later in the slide itself. Now, regarding the slide, you get the slide. You will get an email. Okay, or that consists of this all these slides. Entire slides will be as a single PDF you will receive, and videos are there included. But anyway, I'm not in PDF. You cannot actually add video. So one thing I will do, I will put the proper link there. So you can also use the link. Also, I will in the last page I will add all the links that I referred during the class, something like the link of that ISS and all, so that you can see. And regarding before going to the exam, I will show you one more interesting thing that is make learning more interesting. Just see. So this is NASA Spinoff. Okay, site address is spinoff.nasa.gov, and if you go there, you can click this NASA home and city, then choose home or city or whatever you need. So this is actually home that I have chosen. I hope you can see. So it is actually showing what are the NASA spin-off that is used in a home. Okay, so I can go living room. So what are there in living room? I'm clicking the living room. It will go there. So it will show many things. Okay, see. So wherever there is a clickable link, actually you can click on there. Okay, see. Okay, for example, this one, better carpet. Okay, cleaning. NASA and industry collaborated on handheld device that evaluates the effectiveness of carpet cleaning system by measuring the amount of soil they remove. The device, a portable NASA X-ray sensor used to detect invisible barcode and analyze chemical on the spot, now looks for unseen spots in carpeting. So the efficiency of a carpet cleaner is actually tested by the rocket technology, and that is how we have this thing. Now you can see another blue light cancellation. Okay, you can see blue light cancelling. This visors are there that you get. That is also again NASA designed filters helps block the 95% of blue light, making it easier for skiers. So it is actually used by maybe skiers and cyclists. Everyone actually uses this kind of. So you can see. Also, you can go to a city like this. That is the other link. You can see a city, and in that city, wherever it is being used, okay, you can click them and see in medical field where it is there, coastal, then maybe public safety. So click on each of them and see what are the spin-offs that is used in daily life. Okay, so that is about today, and a brief discussion on your exam. I'm not giving a class or anything regarding the exam writing because you already wrote both exams and you successfully reached the final level, so you know how to attend it, maybe better than me. Okay, okay. Now the total questions, as you know, it is 30, and as you know, the 50% from the will be from the textbook. That half of it will be from the textbook. That is 15 of them from the textbook, and 9 from this our class actually. Okay, so we completed this class right now, and 5 days topic. So from this topic, you will get especially just learn that slides completely once you get it, so that you will be able to answer. I'm sure that you will be able to answer all the questions, this 9 questions, and 15 from the textbook, and 6 of them will be general but within the syllabus. So there are things which we couldn't include in the textbook, and maybe in the same topic the textbook is not complete, the talk is not the class is not complete. So there are some general questions, so that is needed actually. So then only you will actually go beyond the syllabus and learn things. That is why there are 6 questions, but it is based on the syllabus, but may not be included in the class or in the textbook. That's all. And as you know, the total duration of the exam is 10 minutes online exam, and you know how it happens. Okay, and the right answer is 1 marks, and the wrong answer is actually 0.25. Just a second. That is the negative 0.5. Okay, so there will be a minus mark for that. Okay, so it is a minus mark. So 1/4 of your mark will be reduced if you go for a wrong answer. And also you can actually leave a question. Okay, if you don't know what is the answer, you can actually leave it without going for a wild guess. It is better to leave that so that you won't lose any mark like the negative mark. For wrong answer, there is a loss of 0.25. Okay, so that is another thing I want to explain. And when you write the exam, since it is a multiple choice, actually you can, when there is a multiple choice question, actually you can answer it in 2 ways. That is an advantage of, so for example, A, B, C, D are there. Okay, so I am asking the question is something like, who landed to the moon first? Okay, first option is Neil Armstrong. Okay, okay, already I know that you know the answer anyway, so Neil Armstrong is there. Then I am writing something like say something like say George Bush. Okay, or someone else, something like say uh yeah, maybe someone from other field. I'm not getting any name. So some film star, a name of a film star is here, then another film star is here. Okay, so the names are, so one thing, I'm not giving a wild example. Anyway, the question won't be that easy. It's not that easy, won't be that easy, but anyway, you can see that there are people who knows the right answer. Okay, that is something like, it's Neil Armstrong, I'm sure. Okay, but there are people who doesn't know which is the right answer, but I know that George Bush is not anyway. Then I can, he's a film star, so he might not be, and he might not be. So I can actually rule out the wrong and finally find them. Okay, either I can choose the right one directly, or I can rule out the wrong ones so that it won't be and it won't be, then this should be. Okay, that is another way of answering. Okay, in multiple choice question. Okay, and I suggest you don't go for wild guesses, but sometimes you can actually guess when there are only two options. Okay, so sometimes, like, imagine that, assume that this comes something like a Buzz Aldrin is another option, and this is a film star. So you rolled out this two. Then I don't know, Neil Armstrong or Buzz Aldrin. In that case, you may, okay, I'm not suggesting to guess, but anyway, if you want to have a guess, only guess in this situations. Okay, when you rolled out two of them and you are only remaining with the two options, then you can. Okay, so that's about today.